replace retraction very easily as well. And so I'm just doing the mesial here a little quicker, so you can see how we can break contact, and we don't have to hit the adjacent teeth. Now, it kind of looks like a mess right now. You've got a lot of irregularities on the axial walls. So let's equalize the taper, and let's make that nice and smooth all the way around. And for that, I'm going to use the 878K012 again. I've been using that earlier to develop the initial axial reduction and to set the finish line location, but now I'm going to go around and I'm going to equalize the taper. I'm going to see areas that are over tapered and correct them, areas that are under tapered and correct them. I may need to lower the finish line slightly so it's more uniformly above the tissue. I'll smooth off the transitions so I won't have any sharp edges between the surfaces. If I have an area like here on the distal that seemed a little bit over tapered, I can upright that wall a little bit as I lower the finish line. We can get a little bit more bulk. We're definitely going to want to have a little bit more bulk for the metal on the lingual here and for the ceramic in other areas. So we can get things a lot closer with the 878K by going around this step. You know, when I learned this preparation, I was never taught this. I was taught you had to do every step just ideal, and I always felt that it was just too difficult to do that. So it's kind of nice to have this system in place where you can go back and refine things. This is the secondary plane, and this is done for contour purposes and for the need to have adequate thickness of the ceramic. You don't want to prepare that facial surface with just one plane. It's got to have two planes. So when we move on to the chamfer refinement step, we're going to utilize this 8877009, and my students have always called this the chamfer fixer, because it does such a really great job of making your chamfer ideal and having it decline at about 60 degrees. I'm a little bit discouraged sometimes when I see chamfers that look more like shoulders to me. They don't have that declination angle. They don't allow you to have a metal seal, a slip joint effect. So when you're doing a chamfer, a true modified chamfer, you want to have them decline like these here. So let's now create the shoulder. And you notice that we're doing the FGC kind of prep first, and now we're going to convert this to a PFM by further reducing the facial, creating a shoulder, and then also removing a little bit more occlusally. So the location of the shoulder on the mesial starts at the facial aspect of the interproximal contact, and then the shoulder extension on the distal does not need to go that far interproximally because it's not an aesthetic area, it's just over reduction. So let's make sure that we're into the contact area here so that when the patient smiles, but on the distal, just go over to the line angle between the distal and the facial. I might need to move that over a little bit more distally. So maybe right there would be better. Moving that shoulder interproximally on the distal makes no sense to me at all, and it's very aggressive. So I'm just highlighting the area of the internal that's going to be deepened from, let's say, 0.5 or 0.6 millimeters deep at this point to 1.1 millimeters deep. More than 1, but probably less than 1.2. So 8847KR016 is the burr we like to use. It's a flat-ended diamond that has a tip that's wider than the RGS3. It's 1.1. Here's the RGS4 just for comparison, 1.5 millimeter. Some people ask for a 1.5 millimeter shoulder. I think that's very aggressive. I don't think that that is a good idea. I own a dental laboratory and we don't need 1.5 millimeters at all to develop beautiful PFM aesthetics. I think that's a significant over preparation. So let's try to save tooth structure and keep that shoulder right around 1 millimeter. Much less than 1 millimeter makes it very difficult for the lab technicians to create a very nice aesthetic final look. So let's try to be 1 millimeter to 1.2. So I like to just say, hey, why don't you just make it 1.1, because that's how wide the end of the burr is. And obviously every time I'm doing action shots here, I'm speeding them up 2x so that we can get through these preparation parts a little bit more quickly. So, you know, it's a good idea to get out the RGS3 as another way to verify, have I gone deep enough? No, not even close. See that? You're not even close. Maybe you've made it a shoulder, but it's not deep enough. So on the mesial it looks good, but on the mid part in the distal buccal area, it's definitely not 1.1 millimeter deep. So we just have to continue. And remember that every time you deepen the shoulder, you're going to want to reestablish the taper and even reestablish the secondary plane, which you may have removed in the process of removing more facial tooth structure. This is also a good time to, there we go, this is a good time to smooth off the finish line too and get the proper shoulder, which is going to make a 90-degree angle between the finish line and the unprepared tooth structure. You can see these little wings that are left over. It's popular in some areas to leave them, but I always have felt that it just adds an added complication to the prep because you have to make those wings have proper taper. They're kind of like a retention groove in some respects. So I like to remove them, and for that we can utilize the KS0F burr. This is kind of an interesting approach because it's 1 millimeter wide. You can see with the RGS3, you can see that it's 1 millimeter wide, and it's round-ended, so it allows you to blend the shoulder into a chamfer by utilizing that round end as it migrates through a transition from a shoulder to a chamfer, and it works out pretty well. So it's kind of a new technique that I'm doing, and it seems to be working really well with students doing PFMs. They're having a much easier time transitioning between shoulder and chamfer. It's sort of an easier way to do it. It is a little thicker, so it's a little bit harder to get between the teeth. So you may have to go back to some other burrs for certain areas, but with a little bit of care, you can usually do a pretty good job transitioning. Yeah, so it looks like things are moving along pretty well. Let's place some bevels between the occlusal and the axial walls. For this, we can use a carbide like a 7404. You can use a 7102. You can even use the burr we were just using, that KS0F. The key is that you don't want to have any sharp edges between the occlusal and the axial that might impede the lab work and the fabrication of the coping. Any sharp edges could complicate the laboratory work. So here you see the preparation is pretty close to being done. Let's go ahead and check out the clearance. This is an RGS4, so it's 1.5, and it fits easily with a little bit of wiggle. That's what you really want to see. And the typodon's fully closed together, so we know we're not getting an inaccurate measurement here. You can go through excursives just to make sure that you don't have any unseen areas that need to be reduced, previously undetected areas. So take a look at the shoulder. We went with that 1 to 1.2, and there's the RGS3, which fits inside of there, and But on the distal, just go over to the line angle between the distal and the facial. I might need to move that over a little bit more distally. So maybe right there would be better. Moving that shoulder interproximally on the distal makes no sense to me at all, and it's very aggressive. So I'm just highlighting the area of the internal that's going to be deepened from, let's say, 0.5 or 0.6 millimeters deep at this point to 1.1 millimeters deep. More than 1, but probably less than 1.2. So 8847KR016 is the burr we like to use. It's a flat-ended diamond that has a tip that's wider than the RGS3. It's 1.1. Here's the RGS4 just for comparison, 1.5 millimeter. Some people ask for a 1.5 millimeter shoulder. I think that's very aggressive. I don't think that is a good idea. I own a dental laboratory and we don't need 1.5 millimeters at all to develop beautiful PFM aesthetics. I think that's a significant over preparation. So let's try to save tooth structure and keep that shoulder right around 1 millimeter. 6016, much less than 1 millimeter makes it very difficult. 016 for the lab. But basically, start off with the C plane, nice, and you want to use the burr to your advantage. And understanding that the thickness of this diamond is 1.6 millimeters at its widest area. Why don't just make it 1.1 because that's how wide the end of the measures. 1.1 millimeter. I'm using the RGS4 as a guide, which is 1.5 millimeters wide. Action shots here. I'm speeding. We can perform this check in the mouth as well. We can get through these preparation parts a little bit more quickly. With the PFM, we're looking at 2 millimeters of occlusal clearance when we're finished. So a 1.5 millimeter depth plane, not a depth cut necessarily, but a depth plane like we're doing here is a very effective technique to get to that 2 millimeters that we're looking for in the distal buccal area. And so we just continue prepping and checking. So we just have to continue. You can see here that remember that every time you deepen the shoulder, so we'll go back to reduce a little bit more and verify that reduction. Even reestablish the secondary RGS4, which you may have removed in the process. There are numerous ways we can check occlusal clearance. We can use putties, we can use different types of matrices, we can use wax, we can use bite registration or bite preparation tabs, which is going to make a 90-degree angle. I find it pretty easy just to go ahead and use this instrument that has a known measurement. Tooth structure. There we go, much closer to 1.5 millimeters. It's popular in some areas to leave them, but once we're done with that mesiolingual cusp, we'll just go ahead and migrate on to the distal lingual cusp and perform exactly the same function across this C-plane, this non-functional cusp reduction that we're doing. But we're not doing it all flat, we're doing it to mimic the triangular ridges. Utilize the KS0F burr. This is kind of an interesting approach. This diamond's getting a little bit worn out, and I can usually resurface it and get a few more minutes of use out of it, but it's just about had it. And so there we go, we're looking at 1.5 millimeters, so it allows you to blend the shoulder into a chamfer by utilizing that round end as it migrates through. Now I'd like to do the A plane next, not the B plane, but the A plane. And so we're going to angle it's kind of a new technique that I'm doing, diamond, and it seems to be working really well with so that it parallels the C plane. They're having a much easier time transitioning between shoulder and chamfer. It's sort of a. And we try to follow the morphology of the cusp a little bit so that we have a rise and fall. That'll allow us to match the opposing a little bit better. But you can see how the A plane and C plane are nearly parallel to each other. After finishing the C plane and A plane, we can now turn our attention to the B plane, which is quite easy because most of it's gone at this point, the upper portion anyway, by doing the A plane. And we just follow the rise and fall of the triangular ridges, including the distal cusp. So there you go, you can verify that you have 1.5 millimeters of clearance at this point. So let's use the RGS4. We know that's 1.5 millimeters wide, so we can just slip it in here and we can see that indeed we do have, from incline to incline, at least 1.5 millimeters of clearance. And after we're done smoothing, we'll probably have closer to 2. I like to make a few dots like this on the buckle cusps after I finish the A, B, and C planes, because if you've done them right, the buckle cusp tips line up with the unprepared teeth, distal and mesial. Looks pretty good. Just make sure that that A plane and C plane parallel each other. Well, why don't we move on to the axial reduction. For this step, I like to use the 878K012. It can make a chamfer for you, but the chamfer is going to be quite narrow, and most of the time you want to have a chamfer that's probably closer to 0.5 to 0.7 millimeters in axial depth. This very skinny tipped tapered diamond won't provide you with adequate chamfer depth. Remember, a chamfer has an angle that's at least 45 degrees downward towards the tissue. This provides that for you very nicely, but it's just a little on the narrow side. It's kind of a good idea to set your finish line location at 0.5 millimeters above the tissue, and then you can always lower it if you need to. If you tend to go subgingival, like so many of our students do, I would suggest you go a little higher up. If you've done this step correct, you're going to leave these little unprepared sections interproximally, and these you're going to remove in the very next step. I like to keep these as narrow as possible buccolingually. Okay, so let's get started with interproximal clearance. And for this, I like to use a needle-shaped burr. This is an 859-010. It's very skinny. You could also use an 850-012. Some people even use 169L. So anything of that nature can work quite well. There are really 3 keys when trying to break interproximal contact. One is don't go too deep axially, don't over taper, and then don't hit the adjacent tooth. And it's tough to do the first 2, but we can definitely protect the adjacent tooth by leaving a little sliver here, and that works out pretty well. Remember, when we're doing this interproximal clearance step, we are not interested in developing a perfect finish line. We're just interested in clearing the tooth from between the teeth and if the tooth structure. So if you can just focus on that's really helpful. Sometimes we get so worried about hitting the adjacent tooth, you tip the burr in towards the prep you're doing and you over prep, or maybe you over taper. So it's important just to think about just breaking contact, and your margin is going terrible at this point. You're really not going to have a very pretty looking finish line. I'm just lowering it down a little bit so that we have at a very minimum 0.5 millimeters of space between the preparation finish line and the adjacent tooth. This will allow us to scan that area with an optical scanner. It'll allow you to